So here's an idea from physics that if you throw an object such as a baseball up into the air, its height is going to be, well, you take the velocity and the initial height, and this is acceleration due to gravity, and come up with this formula, which will be covered in first semester calculus as well as physics class. But for this one it says find the domain, range, and maximum value. Well, since this is talking about time, the domain can't be negative, but it could be 0. And the 0 would mean at the moment that the baseball is released, what is the height? So if we substitute a 0 in here, then we get the height at time 0 is equal to 6 feet. Well, that's when the domain starts. So it starts at 0, and then we can look at it graphically as well. If this is the time and this is the height, at time 0 it's starting at a height of 6 feet. And then the baseball is going to go up into the air, and eventually it's going to come back down and hit the ground. So the domain, the t values, from 0 to t equals what right here, that's the domain. Well, at this point right here, that's when the height is 0, because it's on the ground. So I could set the equation equal to 0, negative 16 t squared 50t and a 6 set equal to 0, and then use the quadratic formula to find out when is it going to be on the ground. So it's going to be t equals negative the b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So if I do this all at once, it's going to look like parentheses negative 50 plus the square root of 50 squared minus a 4 times negative 16 times 6, and then stop the square root and close the numerator, divided by the denominator is a negative 32. So t equals negative 0.116 actually doesn't make sense because that says go backwards in time, which humans are not very good at yet. I'm going to do the same thing except change this to the minus. If I put second enter, it gives me the whole expression back, and I can change this to be subtract. And then it says 3.241 seconds. Alright, so that's when it's going to land on the ground, 3.241 seconds. And so now we have the domain. So the domain, or the t values, is start from 0, and it can equal 0. That's the moment it's leaving the person's hand, the baseball. And then it goes to 3.241 when it hits the ground. So we've got part of it, the domain. So this axis is telling us the domain, and then this axis will tell us the range. Well, at the very lowest point, it's right here at 0. We now need to find out what about the very highest point. H equals what? So when does it reach the maximum? There's a couple of ways to do this. One is you can take these two t values and find the average, and that will be this t value that's right in the middle. So essentially this one says if you were to go backwards in time, this is at negative 0.116, And if you find the average of these two, since the graph is symmetric, that'll tell you what's in the middle. Another way to do that is use this shortcut formula, t equals negative b over 2a, which is actually this part of the quadratic formula, negative b over 2a. So negative 50 over negative 32 so negative 50 divided by negative 32, 1.563. And I just want to show you, if I did it the other way and found the average of these two, it's going to end up with the same thing. So if you add negative 0.116 and 3.241 and divide them by 2 to find the average, you get the same thing. So that's going to be the moment after about 1.5 seconds when this thing is at the highest point. The baseball is at the highest point. But what is that highest point? So then we need to find out what's the height at 1.563 seconds. So that's going to be my domain information. This is going to be my range information. So go back to the original function, substitute this in, negative 16 times 1.563 squared plus 50 times that value plus 6. And now another thing that I can do to verify that I'm doing this correctly is graph it and make sure that the graph matches up with what I've got over here. So go to y equals negative 16x squared plus 50x plus 6. And for the window, I can have it go from negative 1, and this goes out to 3.2, so let's say I just go to 4. And then for the height, 0 to, I'm not sure, but I'm going to try 100 feet for baseball and see how that looks. Yeah, not bad. Alright, one thing to verify is that that value over there is 3.241, so if you just go to trace and type in a 3.241, well, it doesn't say that it's exactly equal to 0, but that's because this has a little bit of rounding error. If I were to type in this whole radical thing, then that would say exactly 0. Alright, the next part I wanted to do is find out what's the maximum height. So substitute this into the function. So trace 1.563. It should put the cursor right here at the top. Yes. And so it's 45.062 feet. 45.062 feet. And now we have the range. So the range is that at the very lowest, the baseball is on the ground. That's a height of 0. And at the very highest, it's at 45.062 feet. Alright, there's domain and range. And the other was the maximum value, but that's what we just found right here. So the max is 45.062 feet.